Okay, so Thursday, December 3rd, 2020, we're going to go through the portfolio first. And again, there are items on there with reproductive, obviously, we haven't gone through. So some of that will be a little bit new, but the rest of it, I think you'll be just fine with. So, and again, this is a pretty well, let me go back here real quick. I want to discuss points just to eliminate confusion too. Then we're going to do reproductive. I put the totals. A few students have emailed wondering what exactly, the grade book, and I don't think they came to class the other night because we kind of talked about it, but I'm going to put it in here anyway. So you have 12 total Padlets at 10 points apiece. There are 120 points total for the Padlets. So, kind of nominal. It's less than 10% of your grade. So again, you shouldn't be spending too terribly much time on those. Now the portfolios, those are, we did 9 units and 14 chapters condensed in a variety of different ways, right? The beginning of the semester, we had the portfolio and the lab visible body were separate. But one was 30, one was 20, combined they were 50. I think we did that about the first 4 or so weeks or 4 units. Then we condensed everything to being portfolio lab assignments combined. So then those are 50 points. And then as we got into unit 7, unit 8, unit 9, we started to put more body systems together in one unit. So the point values started going up. So you had 2 body systems in one portfolio, it'd be 50 plus 50. So that would be worth 100. Reason I'm bringing this up is this last portfolio is 4 body systems. So it's worth 200 points. So it is a little bulkier and a little beefier, particularly with the terms. So anyway, total your portfolios, lab assignments, visible by everything put into a nice little box is 700 points. So that's half your points. 50% of your grade is doing your portfolio. So it's a pretty big chunk. And then you have 12 exams. Those are all in there, not counting the final. 12 regular 40-point exams. So that bumps you to 480. And then you have a final exam that's 100 points. So all told, you're looking at, again, around 1,400 points. All right. So hopefully that all makes sense. That's what's there. And again, that's what your grade book looks like. I'm just about done. I think after, by the time I go to bed tonight, I think most of the grading for all my classes will be uploaded into Blackboard. So you should be, when you guys wake up in the morning, if you've turned anything in up to this point, you should have or done Padlets. Those should be uploaded into Blackboard as well. So anyway, all of your grades up to today should be done. So everything that you basically have about 8 days so you can see where you're at tomorrow morning on the 1,400 scale. So if you're at 1,000 points right now out of 1,400, you're doing pretty well. You're on your way. If you're at 300 points out of 1,400, you've got some ground to make up over the next 8 days. It's possible. I mean, I've had students at 0 going into the last 2 weeks that somehow managed to give me a whole hell of a lot of work to have to grade from the past. But hey, it's my own fault for letting them turn things in late. But most of you should be in that 700 plus range after tonight. So anyway, keep that in mind. You do still have portfolio 9, portfolio 8. I think several of you have turned in, so that'll be graded. Portfolio 9, again, that's 200 points. And then the final exam is 100, and then probably at least the last 2 exams. So you still probably have 300-400 points out there minimally if you're kind of caught up. So you'd maybe be around 1,900. But yeah, if you're at that 600-700 range, you're doing okay. You're probably in unit 7, unit 8. That's good. You can make up that ground pretty pretty quickly over the next 8 days. All right, so let's move forward. And again, just email me if you have questions as we get closer to the deadline next Friday night. Again, I'll be grading as things come in over that time period. So you'll see your point value increase. So just, again, I don't know if you need an 80% for a B, then whatever 1400 times 0.8 is. I don't remember. It's like 1120 or something. So, so anyway, that zoomed down. So let me get back to the top. I don't know what happened there. Okay, must have hit end page. Okay, so anyway, so so definitions. There's probably about 40 or 50 for each of these body systems. So the first 40 or so are going to be from respiratory. And again, these are how you do these. I get a variety of different answers. It's kind of interesting to see, throughout the semester how all of you are approaching doing these. So so anyway, first 40 or so, I think for the most part, I don't think there were any oddballs. Boyle's law, there is, again, I try to keep the physiology stuff at a minimum, but Boyle's law, atmospheric pressure, tidal volume, those last couple in the mid to upper 30s, they're going to be a little more physiology-ish, but that's okay. You're, again, just a tiny bit isn't going to hurt you. So next semester, when we talk about tidal volume, expiratory reserve volume, inspiratory reserve volume, we dive pretty deep into that. We do a couple of different labs with respiratory volumes, respiratory physiology, but yeah, those are in there as well. So Boyle's law, it talks about, I've kind of talked about a little bit, volume and pressure being inversely proportional, right? When the diaphragm flattens out, pulls the lungs down with it, that it causes an increase in volume of the lungs, which decreases the pressure in the lungs. And air moves from high pressure to low pressure. So higher pressure out here, lower pressure in the lungs, as the volume is increased in the lungs, basically forces air to come in to the lungs. It goes from a higher pressure to a lower pressure. So we get into that in a lot more detail next semester, but it's not going to hurt because we have talked about it and we have looked at it. But yeah, there's a law for it. So and that's Boyle. Pressure and volume are inversely related to one another. All right, and then that takes us to the 40s range, gets us to digestion. Still got my jug. It's gone down a little bit, not too terribly much. But anyway, so digestion, again, same deal. There are a couple kind of physiology principles, absorption regarding bringing the nutrients out of the digestive tract and into the cardiovascular system. But again, for the most part, these are going to be anatomy related. Okay, in different regions of these organs. Okay. So, pardon me. So now we're out of the stomach, entering into the small intestine. So you have the three. Whoa. So you have the three. Back it up. Boop, boop, boop. There you go. So you have the three different regions of the small intestine, and then the valves. Okay, and then we head into the large intestine. And then gets into some of the accessory organs, the liver, gallbladder, some of the chemistry in the stomach, okay? And then some of the chemistry within the enzymes that the pancreas release. Remember too, guys, and again, this is some physiology, we go through it a lot. ASE is an enzyme. So we right away, 97, 98, 99, you see, and 100, you see an ASE on the end of those. That's indicative of an enzyme. And then what's in front of it, the root or the combining form, will tell you what the enzyme is helping to break down. So lipase would be enzyme that digests fats. Okay, protease enzyme that digests proteins. Okay, so anyway, that's kind of a giveaway when you see ASE on the end of a word. Okay, that takes us right to number 101, which is the urinary system. We did that last time we were together on Tuesday. And again, just goes through some of the basic structural features. Okay, we talked about every single one of these. And again, physiology-wise, there are a couple of questions in here a little later, but nothing too detailed. All right. I don't. Oh, micturition. The urination. The process of forming urine and expelling it. Micturition. Okay, and then here's those physiology principles again: filtration, reabsorption, and secretion. Those, again, just the basics of those three will help us next semester when it's like, oh man, here we are. We made it to the kidneys. We made it to some of these physiological processes. That's about week 10 or 11. So it won't be like, oh no, it'll be like, oh yeah, we know what we're doing. So filtration, reabsorption, secretion, you've heard these terms. You'll see them in more detail. It'll be a slam dunk for you next semester. So anyway, filtration, again, that occurs first. We're pulling things out of the blood, putting them into the urine tubules, and then reabsorption's taking things out of the urine tubules, putting them back into the bloodstream. And then secretion is one last attempt at getting things out of the blood and into the urine. So filtration and secretion get things out of the blood into the urine, whereas reabsorption pulls things out of the urine, puts them back into the blood. All right, so pretty straightforward. A couple of, again, hormones. We spend a lot of time on this batch next semester. We've talked about them a little bit this semester: aldosterone, angiotensin, okay, and ADH, antidiuretic hormone. Okay, so that's all of those. And then that takes us into the reproductive system. So we'll discuss several of these tonight. Again, some chemistry in there, some physiology that we'll discuss more in detail next semester. Again, the bulk of what you'll see terminology wise is going to be anatomy. Okay, we'll go through a little bit regarding fertilization. But again, we spend time fertilization, heredity, genetics next semester. All right, so you'll get introduced to the little bit of the birds and the bees, at least the structures of the birds and the bees tonight. So the next section goes through some of the respiratory system identifiers. Again, these are all pretty straightforward. I didn't really see too many issues with these when I went through them earlier today. Okay, and again, we're looking at primary bronchus, secondary bronchus, tertiary bronchus, and then just the different lobes: superior, middle, and inferior lobes. And it's of the right lung, and then superior lobe and inferior lobe of the left lung. So that it seems kind of redundant, but again, I kind of went a little fast there. But D, F, and H are pointing to the lobes of the right lung. So you want to make sure you put that in your answer: superior lobe of the right lung. Because over here, I and K, you're going to do superior and inferior lobes of the left lung. And again, the digestive system, very straightforward, from mouth all the way through the digestive tract down through the colon, and then gets into a couple of the layers of the stomach. We looked at the serosal layer, the mucosal layers, right? Mucosal on the inside, then muscular, mucosal, submucosal, muscular, and serosa, kind of working our way up from Q up through to M. Okay, and then we have a couple of ducts going on here, showing the pancreas kind of located in the back here, letter I. Again, I think most of these are pretty straightforward regarding the lower digestive tract, getting into the appendix, cecum, okay. Ascending, transverse colon. Letter L, you could put Hostra for that. That would be fine. Okay. M, descending colon, sigmoid colon, okay. Rectum. Okay. Then the anus. And then we get into the kidneys a little bit. Again, looking at I think these we know for sure, right? You probably knew these before you took anatomy. The first one anyway, right? Kidneys, ureters, bladder, and urethra. All right, then we looked at the kind of the inside, got a little more complicated. Maybe, for some of us, we saw the outer region being the cortex, and then we had so letter E, and then letter G is pointing to those columns, okay? And then letter F pointing to those renal pyramids. Then we have, of course, the renal pelvis, and then heading out into the ureters. Okay? And then we get to the nephron. And again, these are in visible body. So if you go through visible body, you'll see these exact images or illustrations. That's where I took them from. Okay. Again, we look at the nephron, and you're going to want to put a little bit of the functionality aspects as well. Reabsorption, secretion. Okay. You don't even necessarily have to put a function. You could put any type of kind of defining feature of these. Totally up to you. It's it's your experience, but I think as far as the labeling, that's what you're going to want to definitely make sure that you have that in, fairly under control. Okay, the function stuff, again, we'll do that next semester. All right, lastly, we've got some female reproductive and male reproductive images or illustrations, so we'll look at those in more detail tonight. Okay. B, E, C, those are different areas of B, just pointing at the uterus, and then E would be the muscular layer, and then C would be that endometrial layer. So E would be like the myometrium, we call it. If you did B, myometrium, E, uterus, that's fine too. Then F is pointing at the cervix there. More, and then male reproductive. So anyway, so we'll go through all of these tonight. It'll be more straightforward, so you'll know exactly what you're doing. And again, you'll want to go through visible body to answer some of these as well. All right, well, let's move on. We've got a couple things to go through with reproductive. Again, I don't want to keep you guys too long. I think some of this stuff you probably already know. So I'm going to, for the most part, go through maybe some of the stuff that's a little bit more difficult to get. So, or that, is a little more oddball stuff. Pardon the pun, oddball. I'd probably be careful talking about reproductive and ball, especially odd ones. See if I get that going too. There we go. Okay, so chapter 27, point 1 and point 2 are going to go through the reproductive systems. So we'll do the male reproductive system first and save the best for second. So again, we go through some of the actual processes of meiosis and the division that occurs to get the gametes formed. And a gamete is a fancy word for a sperm or an egg cell. So we do need a sperm cell. We do need an egg cell to initiate fertilization. And each of those gametes is going to be carrying genetic information from each of the parents. So we'll go through that in more detail towards the end, actually, just like now, toward the end of next semester. So anyway, that's basically what the first bullet's saying. We need two separate gametes, a sperm cell and an egg cell. That's sexual reproduction. Again, that involves a different kind of process of cell division beyond just mitosis, which we see for that second bullet. So asexual reproduction is going to involve what we've kind of discussed early on in the semester regarding cell division and mitosis. All right, so and again, the offspring are going to carry some of the genetics that were expressed coming from each parent. And again, that gets into dominant and recessive. Now, the haploid, the gametes are what we call haploid or half cells. So I think I did put haploid and diploid or diploid in your terminology for reproductive. So haploid just means 20 for humans. It's 23 chromosomes. So that's half. So a sperm cell of the total of what every cell in the body has, which is 46 chromosomes. Those would be diploid cells. So the total cell is diploid, and that's 46 chromosomes. So from the sperm cell of dad and the egg cell of mom, you're going to get 23 from each, making a total of 46 chromosomes. So two haploids become a diploid. Okay. So again, that gets into some heredity genetic stuff that we certainly spend a little time on next semester. So let's get right to it. We look at the male reproductive organs. Actually, I'll kind of discuss them both initially. We see just because there are some similarities to keep in mind, so we don't have to reinvent the wheel when we get to the female reproductive system. We do see both systems having one essential or a pair, right, of essential organs. We're going to see testes for the male and ovaries for the female. Now, those two primary organs, also known as gonads, are going to not only be the primary organs of the reproduction, but that we're also going to see two functions going on from each, and the functions are almost the same. So we're going to see hormone production coming from the gonad. So the testes are going to produce the hormone testosterone. So we're going to see specific cells that have to do with producing testosterone. All right. For the ovaries, we're going to see estrogen and progesterone as the primary hormones that the ovaries are going to produce. So we'll look at specific cells that have to do with the production of estrogen and progesterone. Now, so function number one, regardless of which gonad we're talking about, is going to be hormone production and release. And specifically, again, testosterone, estrogen, and progesterone. Now, the second function that both of these share is one I think is pretty obvious, and that has to do with gamete production. So sperm cell production, egg cell production. So we need to, it is called the reproductive system. So not only do we need some testosterone, estrogen, and progesterone to enable some basics of reproduction, but we need those, and we'll see shortly, for a lot of other reasons as well. So testosterone plays a role in growth and bone lengthening and all kinds of other stuff. So those epiphyseal lines kind of seal up, and testosterone plays a role in that. So anyhow, uh, now when it comes to the strict reproductive aspects of blending the gametes, that's going to be the second function of the two gonads. So anyway, keep that in mind as we go. So those will be different cells that have to do with the reproductive portion or the gamete portion versus cells that have to do with hormone production. So anyway, because again, we're in our last body system. We made it, guys. Last body system. Always save the reproductive for the end. I think they do that in case we run out of time, and they figure everybody knows about the reproductive system. So if we don't get there, oh well. But we made it. We put the pedal to the metal, and happen to have even a little bit of time left over for you guys to get done what you need to for the rest of the semester. But anyhow, gonads, testes, gonads, ovaries, reproductive aspects. And again, we'll see. So anyway, all semester we've been talking about cells, right? And then tissues. So we're going to see the same thing here. We'll look at the different cellular structures that produce, and cell types that produce the hormones. We'll look at the cell types that produce the gametes and those names. So anyway, accessory organs, kind of the same for both. These are going to, for male and female, there's going to be tracts. So we're going to have tubing, which is going to involve ducts. So generally very similar in structural makeup, a little bit different in the names, and a couple of extras here and there for the male reproductive system. So we're going to see a few extra glands. Now, when it comes to some of the supporting structures, we will see the female reproductive system does have more in the way of supporting structures. They're called ligaments, right? You've heard ligament, generally we think of a bone connecting to a bone, but we also see ligaments connecting soft tissue and soft tissue. So we'll see that in order to keep the uterus and the ovaries and the fallopian tubes all pretty well in place, we need a series of several ligaments to accomplish that, or supporting structures. So, but anyway, so keep that in mind too as we go. Not just the differences between the reproductive systems, but the similarities for sure. All right. So anyhow, here's your first illustration of the male reproductive system. We're going to give you kind of the basics of the tubing and where we start and where we end up. So we start down in the testes, of course, and that's where we're going to find not only the production of testosterone, but we'll also find sperm cell production. So, and really that goes on for males, from puberty all the way to the end. So now, the levels of testosterone, sperm count, that certainly does decrease with age, usually by the 70s, 60s and 70s, that starts to go down quite a bit. But it still doesn't mean that there aren't sperm cells being produced all the way even up into our 80s and 90s. Not that we need to be fathering children that old, but I don't know. I went to high school. I'm from the farms, and there were a couple guys in high school. Their dad, when we were like 16, their dad was like 78, 79. So he was in his 60s, and still having children. So I mean, it's not out of the ordinary. So, but anyway, so the testes produce the sperm cells. They're going to mature a little bit in the testes, but they're going to spend more time in their little finishing school called the epididymis. So that epididymis is where we're also going to start to see our first real kind of what we call seminal fluid. So the ejaculate is going to be made of seminal fluid, and sperm make up a very small percentage of the total volume of semen. So the epididymis is going to provide the first kind of, the snacks, the sperm cells have a long way to go, you guys. You're you're gonna see they need to eat. You know, they have little tails, right? They have to swim. They have to go all the way from the testes. They have to dipsy doodle up and around and pass through here, and then, well, they're not gonna come out this way, but some direction, right? And they're gonna ultimately get into the vaginal canal, past the cervix, into the uterus, into the fallopian tube. That's a long ways to go. So keep that in your train of thought as well. Just how amazing fertilization and how amazing life is, and how amazing each one of you are. That one individual sperm cell and one individual egg cell, poof, and here you are. Yeah, looking at your computer, wondering about the birds and the bees and the flowers and the trees. So anyway, next semester we'll talk more again about the kind of the real, I guess, beauty of, and I mean, I don't know. It's science gets into, this is, but there's chance, there's divine intervention, there's so many levels that we don't know, but we do know that the sperm cell, as we start to look at where it comes from and go through these mitosis into meiosis processes, even more amazing how unique each and every one of us are, and how difficult it is to just say, yep, we're all even twins, certainly have some different coding. So, but anyhow, so those testes are going to release the sperm cells, are going to get into the epididymis, kind of hang out there, get their first little snack. Okay, they need a lot of glucose, fructose, and other sugars. So our first little bit of seminal fluid is going to come out of that epididymis, feed the sperm cells, and then we're going to start traveling up through the vas deferens. And you've heard of that one. You maybe didn't know it, but I think all of you, as I kind of squirm, I haven't had that happen, and I won't. But yeah, vasectomy, the idea of any type of lasers or scalpels or needles anywhere near my privates is really. I'm not even fond of a needle in my arm, right? A tetanus shot or a booster shot or giving a blood draw. I'm more into the powers of other things than needles. Yeah, but especially toward the nuts. Yeah, no thanks. So anyway, so vasectomy, we could make a little incision. Of course they're going to numb it, and then they put a little crochet hook in there. They pull that whole little area out. We're going to see there's more than just the vas deferens. That's called the spermatic cord. There's going to be some blood vessels, so you have to be very careful, with all of that. But yeah, they put the little crochet hook, pull that baby out, and cauterize the ends and stuff everything back in, and off you go. You go back to work. No pain vasectomies nowadays. So like drive-through windows, right? Just pull up and dangle it out, let them zip and drive off. Yeah, stop, get a cappuccino on the way in and a apple pie or a sundae on the way out. So yeah, and it may be an ice pack too, I would think. But anyway, yeah. So, yep, that's called a vasectomy, vas deferens. Yeah. Well, are you still going to produce sperm cell? Probably. Yeah, they're going to get there's enzymes there that are going to break them down, but they're not going to have anywhere to go. Are you still going to produce testosterone? That's a big deal too. Absolutely. We're not removing testicles. Hopefully, I'm sure some would beg to differ, right? But they used to do that. The castration. The eunuchs and things like that. Boy, you can create some real obedient folks if you start pulling testicles out. So, it also doesn't you're not going to get the same person afterwards. That's for sure. So maybe a little higher pitch. There's a in music. There's a name for these guys. It just slipped my mind. They're males, and this is back in like classical music era, like Mozart and that. But the really high pitch. They can go really sound like females, operatic voices, but these are males. And yeah, they were, they were removing things, and there's a name for that. And I can't, well, I mean, other than castration, but when it castrati, well, duh, yeah. Yeah, sometimes you just keep yapping, things come out and they end up coming together. I bet coming together. Yeah, anyway, castration, the castrati, you should look that up. No joke. CASTRA. Here, I'll type it into the chat. You guys are quiet. Let's see, castrati. Castrati. Let's see. How does the epididymis become inflamed? Well, any inflammation, Carolina, for the most part, inflammation is going to either be in an infection of some sort. So oftentimes that's going to be the case. Epididymitis, it's called. So if you just take off that IS and you add an itis, you're going to have epididymitis. So just take I guess you just take the S off really and add a TIS. Yeah, so infection, definitely. So that's going to be your first thought when you have inflammation of anything. Now, repetitive use, overuse, friction, dehydration, those can all lead to inflammation as well. We've even seen environmental like if it's skin inflammation, it could be topicals can certainly, so allergic so anyway, what causes inflammation? Infection, allergic reactions, friction, dehydration. So that's really, and that would hold true anywhere, anywhere in the body, including the epididymis. Could be trauma. Okay, there's some. It can if it happens in a child, like an infant or something. We'll see this toward the end of this slideshow of the male reproductive system. The descent of the testes is quite a process. I mean, there's a lot of moving parts. So sometimes that process that can cause some epididymitis. Again, could be trauma, testicular torsion. Okay. Oh, okay. It took care of itself. A lot of times it'll maybe go away. If it doesn't, then certainly, again, there could be, sometimes they'll say as they get toward puberty or they get older, then it'll kind of take care of itself. Plus there's a lot of action going on down there anyway, as we get closer to puberty. So again, yep, that can cause inflammation. It can cause, it could be painful. The other thing too, especially with boys are active, right? I mean, most kids are active, right, in general. But if you have a boy who's active in sports, it's extremely important to make sure they have support down, not parental support, like go Johnny, but yeah, nut support. They need a jock strap. They need something no boxers. We don't want to send our kids out running around, shooting hoops, jumping and bouncing and sliding into bases wearing boxer shorts. That's a bad idea. You get what's called testicular torsion. You can get, yeah. So even swimmers need to make sure that they wear a jock strap, because, you get in the water and a lot of action, and there's, this is we have very few perils, trust me. I mean, one of the men, we may complain, but we don't have anything to complain about. But one thing that can get a little weird is, external genitalia. Gonads being, anyway. Yeah. So you have to be careful. Absolutely. Oh man, and if you like baseball, you want to wear a cup, even if you're not a catcher. Maybe a pitcher, they can have soft cups, but man, if you're an infielder or something, I mean, one good hard line drive or short hopper to the gonads, that could be a life altering event. So you definitely want to protect the family jewels, right? You want to make sure they're protected. So anyhow, well, that's it, right? That's right, Lori. Gravity can be oh, right. So yeah, yep. Gravity plays a role too in this. Yeah, we don't for you guys too, right? Everybody. So yeah, you got support, family support and family jewel support. But yeah, so Carolina, he's good now though, right? He got everything figured out, straightened out, and
Yeah, he's doing a lot better now.
awesome. Yeah, because that's speaking as a male, that's scary. I mean, so good, excellent work. All right, so let's see, epididymis. Oh, vasectomies, vas deferens. Okay, gonna keep traveling. Oh yeah, there's so much nerve and blood supply down there that when there is a hitch or an inflammation, anything, something, whether it is trauma, infection, allergy, whatever it might be, oh man, or just a congenital issue that maybe we didn't know about, that as the child grows it starts, it shows up, and yeah, thankfully, yeah, our nervous system is extremely peaked, if you will, down in this, and we know that already, right? Especially with they're highly sensitive area, and that's a good thing, because we need to know, because again, not only for the perpetuation of our genetic code through reproduction, but also because of the hormonal aspects and the testosterone and what it does for a lot of other hormones in the body and a lot of other processes in the body. So yeah, you definitely, if something doesn't feel right, and the level of tolerance of pain, because remember, guys, the pain threshold is the same for all of us. So as soon as you feel something that's painful, the threshold has been reached. Now, how well you tolerate the pain is different from person to person, and all pain thresholds, depending on the intensity of the inflammation or the pain, you're going to get, it's like the difference between one little spot where you've got maybe one person yelling versus a whole chorus of nerves yelling, because they're all, the whole building's on fire. So that is what we see, especially down in this area, because again, it's an internal organ. The gonads, these are internal organs that are external, and so they're very well protected. They're sensitive, and so when something gets out of whack, you're gonna know it. Okay, now as we travel through the vas deferens, again, we're sperm cells with some seminal fluid. We're going to kind of circle up and over the urinary bladder. We go in front of the pubic symphysis there, up over the urinary bladder, and then we get our first big. This is from from testes to epididymis into the vas deferens, all up to this. That's a long ways for a tiny microscopic little sperm cell. So this is their first big rest stop. This is like, seeing, it's Golden Corral, man. This is like, the super highway, or the interstate, you're pulling off, you're starving, and the seminal vesicle is going to be the first big buffet. So this is where we're going to get some fructose, which is a simple sugar like glucose. We're going to also see citrate, which helps with some of the, again, with eating, and like oranges, right? We got to have our fruits too. They have a lot of good as well. And then there's certainly going to be hydration, right? There's going to be the fountain soda machine. So there's plenty to eat right there. About 60% of seminal fluid is now going. So the ejaculate, 60% of what's ejaculated is going to come from the seminal vesicle. Okay, it's also going to bring the pH of the sperm and the semen at that point. It's going to bring it into a little more of a basic range. So the vaginal canal secretes, and the cervix secrete some acidic stuff, right? Acidic chemicals. So anyway, there's going to be some basicity in here to kind of, help with the process, but mainly it's about eating right now. And not only that, this is takeout, by the way. This isn't, we're going to stop belly up to the buffet and then hop in the car and head out. No, these guys they're going to do that, but they're also they're going to get a to-go bag. In fact, they're going to get a to-go, flatbed, or to-go ocean liner. All right. So they are semen, or it is semen. Yeah, right. So anyway, so they're going to fill that baby up. It's going to be a barge full of food, and they're going to keep heading down now through the prostate gland. And the prostate gland, again, we saw it the other day. That's where we do see kind of that juncture with the urinary bladder meeting up with, and the urethra, right? That leaves the urinary bladder. So the urethra kind of meets up with what we call the ejaculatory duct. Okay, and again, as we leave seminal vesicle, enter into the prostate's going to provide about 30% of the seminal fluid. So we're gonna get a little more acidity. However, the prostate juices are more acidic. So all of that basic or what we call alkaline that we got at the seminal vesicle, now it's brought a little closer to neutral with some of the acidity that the prostate gland adds to the mix. So anyway, so we'll see that coming up shortly as well. And at this point, we're going to join urinary system and reproductive system within that prostate gland. So this is the junction, or the fork in the road, and now we continue, and it's just called the urethra at that point. So as we leave the prostate and continue to travel down toward the penis, we're going to have one more gland and one more last kind of, this is that quick drive-through kind of, maybe a 6-pack of Dunkin' Donuts and a mocha frap, or something like that, right? That's what the bulbal urethra is going to give one last little spritz of a to-go bag of goodies. Because again, these sperm cells need a lot of ATP, so therefore they need a lot of sugar. So that's called the bulbo, looks like a bulb, urethral. It's connected to the urethra. Okay, the bulbourethral gland, or it used to be called Cowper gland, or Cowper's gland. That's going to release the to-go bag that the Cowper's gland gives is going to have a little bit of alkalinity to it. So that's good, because we had alkaline from the seminal vesicle. Then we had some acidity from prostate. Now we get kind of to balance things back out again towards more of an alkaline or slash basic or neutral territory. There, that's where that Cowper's gland is going to come into play. So, pardon me, almost got some spit down the wrong tube. So what we see is, or saliva, what we see is, I've mentioned this 3 times in a row now, pH, pH, pH. So sperm and pH are a big deal. So part of the infertility issues that we've been seeing over the last several years are certainly related to pH. In fact, a lot of problems are related to pH. Okay, prostate cancers are related to acidic pHs. So we're seeing more prostate cancers, testicular cancers, bladder cancers, colon cancers. That's all. Look at, I mean, that everything's right there on the screen, right? Colon, bladder, okay, prostate, testicular. Okay, that's pH issues. So, and how is pH balanced? Remember, respiratory system, and then the kidneys and the urinary system. And in order to keep that pH balance, we have to make sure we're breathing properly. We also have to make sure, so sedentary lifestyle, not so good. We also have to make sure we're staying hydrated and that we're getting the proper nutrition and proper nutrients that are going to, alcohol is a bad deal for pH balance. That throws pH balance way off in the body. So we definitely need to keep that at a minimum or even none at all. Okay. And then certainly we're seeing sugars, excessive amounts of animal proteins. These all play major roles in just environmental factors that we don't know about. Some of the air quality and some of the shots, some of the vaccines, some of the exposure we get just walking outside. It's some of the lotions, some of the again foods and beverages. There's so much out there that can affect our pH balance. So that's why you can expose yourself to that. Some it's unwitting and you can't help it. But that's why sleep and hydration, what you can control, becomes extremely important. So your frame of mind, right? How you cope with stress, how you perceive stress, those alter pH. If we have patients that are in a sympathetic mode, they're in a stress mode all the time, that triggers all kinds of physiological dominoes to fall and pH levels going haywire. And, day in, day out, day in, day out, day in, day out of that, it just leads to some serious, serious issues. And then with cancers and maybe, not so dramatic as the cancers, we see things like infertility. Okay, we see fertility issues. We're seeing them like crazy from both male and female. So yeah, because what's the buffet here? This is, remember, you are what you eat. So all of the buffet that you're providing at the seminal vesicle, the prostate, the bulbourethral gland, it's the same buffet of stuff you're putting in your mouth. So again, just got to keep it real, keep things in mind. Oh, possibly. So hard to say. Determining, no, yeah, absolutely. Well, we're going to transfer or segue into the female reproductive system in a few minutes, and we'll talk about kind of both, like what it's. That's, I guess, what fertility specialists are really trying to determine, where's the problem. Because as we continue through the male reproductive system, remember there's the do we have proper number of sperm cells coming out of the testes? Do we have properly shaped sperm cells? Do we have sperm cells that are able to swim properly? There are a lot of factors to beyond just sperm count, right? Quality and quantity make a difference, certainly. Both. We have to consider both. Now, if quantity and quality are off, then we're having to figure out what causes sperm cell production. And there's a chemical inside of the testes. It's called inhibin, and like the word inhibit, but with an N on the end instead of a T. Inhibin is going to be released by special cells in the testes. That's the target of this of inhibin is going to be the hypothalamus and the anterior pituitary. And remember, or maybe if not, I'll tell you again, the hypothalamus produces gonadotropin releasing hormone. And then that goes to the pituitary and tells the pituitary to release follicle stimulating hormone, something called FSH. Okay, and FSH we'll see has to do with sperm cells. We'll look at LH, luteinizing hormone as well. But if inhibin is in excess, so if I have too many of the cells that produce inhibin in the testes, then that's going to trigger gonadotropin releasing hormone and luteinizing hormone, follicle stimulant. It's going to trigger everything to shut down or slow down. So then sperm count is going to be lower. So we need to first figure out, is that what's going on? Basically we work our way backwards with so many of these different conditions that folks come in with. With fertility, it's even more tricky because we're dealing with the male and the female, and where are the issues coming from? We have a perfectly healthy testes, perfectly healthy sperm count, perfectly healthy hormone levels, et cetera, and so forth, perfectly healthy seminal fluids, perfectly healthy pH. And then as soon as the sperm cells and the semen and everything gets into the vaginal canal and toward the cervix, just the pH shock is too much and the sperm die. So, is it the pH of the female that's causing it? Is there something wrong with the sperm cells that we just don't see that triggers them to basically, kamikaze or commit or just blow up, right? Because as soon as they're exposed to a certain level of pH, they're done, whereas most healthy sperm are going to be they've been able to withstand that pH change for forever. So why is it that this batch that these sperm cells are weak to pH changes? Right, and how do we change that? Right, how do we trigger it? How do we trigger a change? And oftentimes we can't. So then what we do is we harvest the sperm and then we clean them. So the sperm go through kind of like a dishwashing kind of mechanism process. They wash the sperm, they cleanse them, and then they take an egg, and then they or multiple eggs usually, and multiple sperm, and then they fertilize them outside of the body, and then they implant them into the uterus. So sometimes then everything, all systems are go, right? We did everything we could, and even then the uterus flushes them out. So again, it could be pH issues in the uterus. There could be hormone issues, progesterone issues. So then and that's why it's big bucks. If you're unable to have children and you want children, fertility specialist is not cheap. So at least from what I've heard. So, tens, easily 50,000 into the six figures, right? And insurance, I don't think is covering that. I don't know. But so anyway, yeah, there's so many variables. Yep. maybe again, divine maybe there's something I mean, I have no idea. Science is here to help. And sometimes even science, even the best science, go through that whole process and, they're stillborn. Okay. So that's that's a roller coaster of emotion for everybody. So then people look into surrogates. Maybe if we do, we do dad's sperm, mom's egg, fertilize, everything's fine. Now we need somebody else to carry it because somebody else's uterus has a pH that can handle carrying the child, right? So I mean, woo, 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 woo. There are a million ways to get it done nowadays. So and yeah, if natural ways aren't working, then and you have the money, you're going to try anything. Now, so anyhow, but it's complicated, right? It's not easy. I mean, a sperm coming from here and heading all the way through here and getting through all the hoops and hurdles, and then everything happening, and then the baby actually comes out of the fallopian tube and implants in the uterus and is healthy for 9 months and comes out healthy. And I mean, from testy to ovary to to the delivery room. I mean, that's that. Whoa, pretty fascinating, pretty amazing. So I'm going to keep her moving. So that's the main, the rest of the male stuff is going to be just kind of black and white. So I'm not going to stay on those. You can go back and read through. The slides are in Blackboard if you want to, get more information and some of the black and white of it. But again, as far as male reproductive organs, this is the macro scale. I do want to look a little bit at the micro scale, of course, some of the cells that are producing some of these items. So let me hold on a sec. All right, awesome. So let's see. So a closer look at the testes. Again, we see what we call seminiferous tubules, and then we have these little kind of columns in between that are key, or they call them septum. Okay, the septum, a little wall in between. And then these are going to be lobules that the seminiferous tubules are located in. So that's where we're going to find sperm cells within the seminiferous tubules being delivered to what they call the rete testes, and then out the efferent ductules into that epididymis. And again, within the epididymis is where we're going to find actually it's kind of down in this area. There's a little gland that adds kind of the to-go, the drive-up window, if you will, for your first batch of seminal fluid. Okay, we've got a tunic that surrounds the testes. The same thing surrounds the ovaries, the tunica albuginea. Okay. Oh, Leydig. These are the endocrine cells. So let me back up. So in between, so in these areas, notice we've got a blood supply coming in. It's very vascularized in here. Now, interstitial, right, means in between. So in between the cells, interstitial. So in the tissue, you can see there's negative space. Let me get my pointer. So you can see there's some negative space in here. And this negative space is where we're going to find interstitial cells. They also call them Leydig cells. Again, it's a person's name. We're getting away from that proper noun stuff. So interstitial cells, these are going to be the endocrine cells. So testosterone is going to come from these areas. So again, if I don't have spermatogenesis going on, sperm cell production going on in the seminiferous tubules, I may still have functional interstitial cells. So hopefully I do, because then I'm still producing testosterone. Okay, so between the seminiferous tubules are those Leydig cells. You see kind of a cross section. Here's the tunic, the outer layer, and then we have these seminiferous tubules, little circles. And then in between the tubules, that's where we're going to find the Leydig or interstitial cells that are going to be releasing testosterone. Whew. All right, sustentacular cells are next. Sustentacular support and regulate sperm producing function. So now we're at the sperm producing spot. So function number one, testosterone. We see interstitial cells doing that. The sustentacular cells aid in the production of sperm. That includes the slowing down or stoppage. I mentioned inhibin a little bit ago. Inhibin goes after GnRH and FSH primarily, because again, we'll see follicle stimulating hormone plays the main role in sperm cell production. So stimulate the follicles to release these sperm cells, or to promote the growth of immature sperm cells to mature sperm cells. So if this process will go on continually while inhibit. So, but sometimes you know the bag gets full, if you will, and so inhibin needs to come up and say, whoa, 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 we need to put the brakes on. We've got plenty of sperm cells. Before we continue pumping more sperm cells out, we need to get some out of here. So yeah, anywhere between 48 hours and so between 2 days and 7 days, maybe up to 10. It just depends on age and a lot of other factors. Sperm cell production can be pretty zippy, and again, it's once things get full, they got to get out. So there are enzymes though that do that can break down some of the sperm cells, and again, inhibin is going to help. So basically, once the testy gets fuller and fuller and fuller and production of sperm cell keeps going, it's going to trigger inhibin to go up and say, let's put on the brakes. And so GnRH, which gonadotropin releasing hormone, goes to follicle stimulating hormone, and then that targets then the sperm cells to stop or decrease production. If inhibin, so if these sustentacular cells that are producing inhibin are out of control and they've kind of overtaken the territory inside the testy, then that's going to cause a decrease in sperm cell production. So, again, if there's a new set point that's been created for some reason, then, I think, Lori, I would say that it's part and parcel generally. Yeah. So yeah, desire, sex drive, certainly. Is good. So, yeah. So an inhibin will then, it's going to affect sex drive possibly as well. Does this only have an effect? Oh, are you talking about inhibin? I'm assuming, right? Yeah, I would think that that the inhibin is going to inhibit not only sperm cell production but also testosterone, potentially testosterone production, because testosterone does aid in sperm cell production as well. So testosterone levels would go down, sex drive would go down. We're seeing a lot more nowadays T cell, not T cell, thymus T cells, but testosterone cells. There are these T cell clinics, and males can go in and get vitamin boosts and other boosts that supposedly help with testosterone. So now, too much is kind of it's a funny thing, because too much testosterone actually decreases sperm count. So low T levels, low sex drive, low sperm count. But if I get this testosterone level too high to the point where this would be external. So if I'm taking like a PED or a testosterone supplement for got to beef up, bulk up, then that will actually cause a decrease in sperm that actually causes inhibin to go up, and therefore then sperm cell production to go down. So so too much taking of testosterone can lead to sterility, is what I'm trying to say. So, but that's excess amount. Now, again, under normal conditions, again, you know, as we age, you know, testosterone levels naturally kind of decrease. Inhibin then is good, you know, going to increase. So we may see a little bit of sperm cell go down as testosterone goes down as well, and as well as sex drive. Then that, you know, that brings in a whole nother level of how males that are having problems in their 60s and 70s coping with the natural aging process and their manly manhood. You know, then that's where the, you know, the penis pills and the penis pumps and all this start coming into play. No joke. In fact, some of the biggest Medicare fraud that has been uncovered in the last, say, I would say decade, because this has been going on for a long time, involved a company, and I want to say it was Kankakee, Illinois, which is right around Joliet and Aurora, Illinois. And they were sending, so basically, these doctors in Florida were prescribing penis pumps just to anybody and everybody. The patient may not have even known that they were getting billed for this. They're all elderly because there's enough of them who want them. But anyhow, they were committing Medicare fraud, and they were billing out Medicare. And then this company was the middleman in Kankakee was, you know, doing the shell game. And so, yeah, they uncovered hundreds of millions of dollars in Medicare fraud from Florida via Kankakee, Joliet. Kind of a funny name for a you mix those words around to that town and they're talking about penis pumps, that gets things even crazier. But yeah, they got busted. And there's a lot of Medicare fraud that deals with the reproductive system, and particularly the male reproductive system. So why in the hell the taxpayer dollars are going towards penis pumps is beyond me anyway, because that is covered by Medicare, and there's a code for that. So yeah, somebody abused their privileges. But anyway, there's all, you know, they're accountants, you know, that's their job, right? Is to monitor weird numbers. Like all of a sudden, boy, whoop, man, that number went up. What happened? Mass exodus to Florida. So yeah, I can't wait to get old. Yeah. So anyway, all the wonderful problems that await us as the time ticks away. Oh, just have it. Just go to your doctor and tell them, you know, have your insurance cover one for you. All right. So anyway, yes. Guys doing okay? All right, good. I know that, you know, things get wild on Birds and Bees night sometimes. We go off the rails multiple times a week, so it can get hairy. See, I mean, everything you say could be double entendre on a night like tonight. So, whew, gotta, you know. Yeah, Sigmund Freud. Yeah, he was all about and that's where the terms Freudian slips and stuff like that come from, right? But yeah, he was all about the id and the ego and everything related to sex, with the Oedipal complex and stuff like that. Yeah, I'm not you know, if you guys want to get into some really good good psychology, Carl Jung is infinitely more fascinating than Freud, in my opinion. But I'm not obsessed with the reproductive system and the brain, whereas Freud was. Whereas Carl Jung, he's more interested in synchronicity and time, space, and symbolism and hearing. It's like when it's like you're driving down the street and a song comes on the radio and you're singing it, and then you look up and there's a billboard, and at the exact same time the singer sings whatever, some a word in the song or a lyric, you see the same term up on a billboard, or a friend pops into your head and you haven't thought about them in ages, and then you go on Facebook or you go out to your and then boom, something happens and you hear this name pops up, right? We've all experienced it, right? You've all experienced, they call it serendipity, they call it synchronicity, but yeah, that's more what Carl Jung was into. Very fascinating stuff. And if you're wondering about, like philosophical psychology, those are tremendous. Yeah, I think Freud and Jung were compatriots. I think one of them taught the other, or was a pupil of the other, maybe, or at least they taught at the same place. But they're contemporaries of one another. I know that. So anyway, yeah, sperm and testosterone. We've been through this. We know that for a fact. Okay, so again, what do we need testosterone for? Again, it does help play a role with the release and the production. What makes a male, the sex characteristics, male behavior, sex drive, metabolism, protein synthesis, bone growth, epiphyseal plate, more double entendre. Epiphyseal plate plays a role in fluid and electrolyte balance. Yeah, you guys got to be on your toes tonight. Okay. Testes in the anterior pituitary gland, FSH. Again, we've seen that before. FSH with gonadotropin releasing hormone is going to aid in sperm cell production. So inhibin is what kind of slows that down. And remember too, the limbic system in the brain, the central nervous system, regulates sex drive as well, and sexual behavior. So, that's all intrinsically linked with the hypothalamus and pituitary as well. So, it's that mind-body connection. And they used to talk about, the teenage boys thinking with the wrong head. So, again, it's a little louder sometimes, the frequency, when we're in that, those late teens, early 20s for males, kind of at their sexual peak. And then, and it kind of continues. It's more like a sexual plateau, I think, than anything. But anyhow, luteinizing, just based on the chemistry, when we see testosterone and sperm cell testosterone release, sperm cell production, I mean, in fact, I put a graphic in here, I think. I'll come back. We're almost done. You guys have probably heard enough. Yeah, so, at 15, 16 years old, we start to see that increase. The red line is testosterone, the blue line is sperm cell production. And yeah, I mean, you hit 17, 18, you're at that peak, and yeah, that sucker's plateaued. I mean, all the way till you're, into your 80s. So, or we are, Craig and I guess. I don't know if there's any other, I don't know if Ricky's in here tonight too. I don't think so.
Yeah, I'm here.
Yeah. Hey, yep. See, Ricky. Yep. Awesome. Thank you, sir. Yep. So good. Always
talking about us being old or something?
Some testosterone in the virtual Zoom room. Right. So yeah, sticks around for a long time. Now, another fascinating thing about testosterone. Now, let's go all the way back here. We've got right at fertilization and implantation. It's a male, so sex is determined real quick. And we see the first trimester, there's going to be there's more testosterone in that first trimester embryo into a fetus, because it's an embryo the first 8 weeks, and then weeks, from week 8, 9, all the way to week 40, it's a fetus. So So that first trimester is like the first 12, 13 weeks or so. So it's an embryo here, and then it just, transitions into a fetus, and we see the testosterone levels go up. I mean, the testosterone levels in the first and the second trimester fetus are almost as high as they are when the kid hits, 17, 18 years old. That's amazing, right? But remember, you don't see a blue line over here though, right? You don't see sperm production. You only see testosterone. Remember, when we go back, if we went back and looked at the functions of testosterone, you would see metabolism, protein synthesis, bone growth, okay, a lot of metabolic processes going on. Well, geez, any of you who, well, all of you, know that baby from, toward the end of, that 12-week mark up until, that, 30-week mark or so. I mean, that's big growth time period there. And then, the testosterone levels decrease to the point, that at birth where they're almost back to being flatlined. And then that first year of the baby's life, especially the first 6 months, kind of peaks out, and then it starts to trickle down again. We see another big peak in testosterone in that little bugger. And again, right? Their teeth are, everything's growing. It's crazy that first year from birth date to first birthday. Mind blowing, right? The amount of change that goes on. It's like the head makes up the whole. It's like you've got it's like a watermelon on a toothpick, and then eventually everything becomes a little bit more proportional, and that takes a lot of growth. That takes a lot of bone lengthening, a lot of teeth eruption, a lot of change. So man, look at that, right? And then yeah, we hit about a year old, and then flat line, and you would know that you can't tell the difference, really testosterone wise between a male and a female from age, 1 year old till, 10, 11 years old. And then at that point, some of the secondary sex characteristics start to come out. We see, facial hair. I was shaving it early, to probably 11 or 12. I probably should have been at like 12 or 13, but it was blonde, so you couldn't really see it. But yeah, I mean, it's things, armpit hair, BO. Carolina, you're experiencing it, right? You've got a 12-year-old. He's stinking up the joint. I guarantee it, right? Whereas 3-4 years ago, he didn't. He was still a little bugger, right? I know. I've got a 13-year-old and almost 14-year-old daughter. Yeah, shoot, the door's open this room, but yeah, don't tell her. But man, there's sometimes it's like, man, didn't you just take a shower? But yeah, man, there's all the smells start coming. So, but anyway, yeah, and for males, we're in it for the long haul, right? At that point. So anyway, then you see sperm cell production also taking place. But yeah, so second, the voice, cracking and, changing and stuff like that. And again, the sweats and the attitude, right, that comes with it. It used to be, all mom and dad all the time. And now it's, mom and dad, brother. I can't wait to do. Yeah, I'm just going to go to my room and read. Yeah. Okay. See you later. Kind of sad, right? It's part of the transition process, right? Of kids. I'm sure my parents, all of you, right? It's just the way it is. It's growth. So, yeah. All right. Anyway, let's get out of the male reproductive system. I think we're good. I did want to show you this though. Anyway, so we saw these seminiferous tubules, epididymis. Now let's take a quick peek here, and then we're going to go to the female reproductive system. So we've got a cross section of a seminiferous tubule. Now at the kind of in the basement. So just like kind of we saw with epidermal skin cells, the basement, remember the stratum basale or the stratum germinativum, that base area, that deep area, that's where we're going to see the immature cells. That's where we're going to see the babies. It's like the nursery down there. That's where what they call the spermatogonia. And then as the spermatogonia mature a little bit, they become spermatocytes. And then these mature sperm cells they mature into becoming what we call spermatids. And then these guys ultimately then are now a mature sperm cell. So gonias, cytes, tids, and then ultimately a sperm cell. And again, these sustentacular cells, these are the ones that produce the inhibin. So again, as this gets fuller and fuller and fuller, sustentacular cells, which are going to be, they're in this negative space there between the sperm cells. As real estate starts to run out, the sustentaculars are again going to release some inhibin to get the brakes put on some of the sperm cell production. Now, as we look at a sperm cell, we do see that it has three main sections: the head, the midpiece, and the tail. The head, of course, is the nucleus of the cell. It's a cell, so it's going to have a nucleus. And the nucleus of that cell, of course, just like every cell, is going to have a lot of DNA. So the nucleus is carrying the genetic information that's going to combine with the genetic information of the egg. And then at the top of the sperm, it has a little hat called an acrosome. And that acrosome, as sperm cells go through what's called capacitation, which just has the cap. It's kind of like removal of the cap. So we're going to get the cap removed. We're going to get some enzymes going. So that acrosome is going to have to come off so this head can burrow into ultimately into the egg. So anyway, that's kind of a little protective helmet there. And then we've got the centrioles, and again, those deal with replication of the DNA and vestiges of DNA replication within the nucleus. And then in that mid-piece, we find the mitochondria. And again, whenever you guys see mitochondria, you're going right to ATP, energy, that type of thing. Okay, so this is the motor. Mitochondria is basically the a lot of M's here, triple M, 3M, mid-piece, mitochondria, motor. Okay, that's the motor that's running the tail of the sperm cell that's going to enable it to have mobility or motility, locomotion. So we could have perfectly normal nucleus, acrosome, but if the mitochondria are iffy, remember mitochondria have their own DNA as well. So we could have some mitochondrial DNA issues that aren't enabling that aren't enabling energy or ATP to be working as well as it should to provide the oomph that the tail needs to swim properly. So I mean the issues are endless, I suppose, when it comes to infertility. Citrate. I mentioned prostate. I think I said citrate with seminal vesicles. This prostate is what pumps out the citrate, and that citrate, again, we're going to have kind of about 30% of the semen volume coming from the prostate. It's going to add a little bit of acidity to the blend, and again, we want that to be more basic or even neutral. So the seminal vesicles, the first spot we go to, that's about 60% of the volume of semen comes from there. And again, fructose is going to be the main ingredient from that buffet. And then lastly, the bulbal urethral, again, they're going to secrete a little bit of alkaline fluid and a little bit of extra go juice as well to, again, enable the sperm cells to make it all the way to where they need to go. All right, so we do that. Oh yeah, the descent of the testes. Again, we're going to see kind of we're going to see this muscle coming down and attaching to, it's called the gubernaculum. That's probably one of the more fun names you'll see in A&P. And the gubernaculum is like a ligament, basically, that's going to connect with the testy. And we have to create kind of it's called an invagination. So you could see this, an invagination is like a tunnel or a tube that gets produced or created, and that's going to allow the testy to be pulled and descend down into what will ultimately be the scrotum. So you can see this long muscle, the cremaster, that comes all the way down, and it's abdominal muscle here that attaches onto the pubis. Okay. So we've got this invagination, and then you can barely see it, but there is an epididymis right here where the red dot is, and there is a spermatic cord or a vas deferens kind of coming up through here. Okay, so this is actually going to seal up right here, this invagination. Okay. So sometimes a testy won't descend properly. Okay. Usually with age, if there's abdominal issues with the newborn, or that can affect the ability, if they have a distended stomach or something wrong with their abdominal muscles, they could have a hernia of some sort as well, and that can draw up, and they call it cryptorchidism. So kind of like the testy is the orchid, the crypt is up here, so it's kind of hidden, hidden testy. Anyway, female reproductive system. We'll look at a couple of items, just like we did a few minutes ago with the male reproductive system. We'll start with the primary reproductive organ, the ovary, and then that's going to be connected certainly then with the fallopian tube, or the uterine tube, they're calling it as well. That's where fertilization is going to take place. And the other thing we see is all kinds of ligaments. I mentioned that earlier. I've got a slide in here coming up shortly that goes through quite a few of the different ligaments that are contained. All right. So anyway, the fallopian tube is going to dump into the uterus. Okay. And that's where the egg is traveling. And if it gets fertilized, the fertilized egg will come down from the fallopian tube and implant itself into the uterus. Now, if it doesn't get fertilized, then certainly the egg will continue, and then we'll get a endometrial shedding and a period, or the menstrual cycle, or menses, they call it. Okay, so that's pretty much that for ovary, fallopian tube, and then uterus. We'll look at a couple of the special layers, the endometrial layer, the myometrial layer as well. We'll see the cervix being the opening into the uterus, and then finally the vaginal canal, and then out, okay, into the what they call the vulva region. And again, we saw last week, and then we'll move on into some of the details. But again, we've got digestive tract, you've got reproductive tract, and you've got urinary tract, all in the same general vicinity of one another. Here we go. So we get another look at the ovary and how it's linked with the fallopian tube into the uterus. Now, this one shows us the terminology of the lining. Again, the endometrium, and then the muscular part, the myometrium. And then we have, again, more ligaments. The broad ligament is probably, and there's one on each side. So this is probably the most well-known, or the one that you would maybe be tested on, the broad ligament. And then we see the cervix and the cervical opening, what's called the fornix of the cervix. Okay, and then the vaginal canal. These little fingers are called fimbriae that come down onto the ovary that kind of help not only keep it in place, but they can help with some of the during ovulation. to get the as the ovary is ejecting an ovum or an egg. And again, we see that tunic. It's the same thing around the testes. And then within the ovaries, we're going to have what are called primary and secondary follicles. That's where the immature sex cells or the immature oocytes or immature gametes are located. So these are the oocytes are the spermatocytes of the female reproductive system. Okay. So immature female sex cells are located in primary and secondary follicles. We'll see that in just a minute. And then the medulla is going to be the internal aspect of the ovary. So as we look, we can see again that that outer tunic, and then we're going to have the cortex or the cortical area, and then the medullary area down here in the middle. Okay, just like we saw with the adrenal glands and the kidneys. Okay. Now this illustration it's kind of like the composite cell where you get everything at once, even though it may not all be going on at once. Or so this isn't, I guess, representative of what's going on all of the time. Okay, so this is like step one. So we would have the primary follicles, where the initial immature oocyte that eventually is going to be the one that gets ejected during ovulation. So then, as time goes, we get in, it matures a little bit more. It's still immature into what they call a secondary follicle. And again, you can see we're getting a little bit more space. What's called the antrum is forming. There's going to be some blood supply as well. And then we end up with what we call the Graafian follicle or the vesicular follicle. So it's almost like the tertiary. So it's like primary, secondary, tertiary. And that last Graafian or tertiary or vesicular follicle is now where we have a mature oocyte at this point. Okay, the mature oocyte then gets released during ovulation. Okay, so we'll look at a couple of the hormones, of course. We'll see FSH and LH again. Okay, FSH is going to be, remember, it's follicle stimulating hormone. So FSH is going to be responsible for the ovulation aspect. Okay, whereas LH or luteinizing hormone is going to be related to the corpus luteum and the production, the endocrine aspect, the estrogen and progesterone that gets released. Okay, so anyway, the oocyte is going to get released during ovulation. Okay, and then that's going to trigger the, and by the way, there's some blood along with that. Many women during ovulation will, I should say women, females during ovulation will experience a little bit of spotting. Okay, so you may, they're like, oh my God, I just had my period. Why am I spotting so soon? And then it goes away. It may be because you released an egg. You may have ovulated. So some women even say that they can almost feel it sometimes, or like it hurts a little bit. I say women. I guess, you can't, once you start ovulating, you kind of become a woman, I suppose. So, but yeah, the female, I guess. So anyway, when a female ovulates, sometimes they say they can actually feel it, or they might have a little pain in the ovary. Again, I don't know. Yeah, like a cramp, and you're like, I shouldn't be cramping. I'm not, I'm not in premenstrual area. I'm in, pre-ovulation, post-menstrual, pre-ovulation. Yeah, absolutely. So cool. Yeah. And then, like I say, some have spotting that go, there you go. And it alternates, I think, too, right? You maybe 1 month it's the right side, another month's the left side, or maybe it's consistently one side too. So, but anyhow, yeah. So I'll circle back around to ovulation a little bit more in a sec. So corpus luteum also we see kind of degenerates as while the ovary kind of hangs out in the fallopian tube for maybe maybe a day or two, 24 hours at the most, is, so it gets released in the fallopian tube, and 24 hours, 48 hours later, if it hasn't been fertilized, it's, that's when we get to this degenerating corpus luteum, corpus albicans, these are what are prepping estrogen, progesterone, and ultimately the endometrial lining. So so basically an egg, when an ovum gets released, the body is assuming it's going to get fertilized. So the body preps. So as soon as ovulation occurs, the corpus luteum triggers estrogen and progesterone they stay kind of plateaued for a few days. We see this endometrial lining where baby's gonna, if fertilization takes place, we've got a nice spot for the placenta and for implantation to occur. So if fertilization does not take place, then the corpus luteum into the corpus albicans. So alba means white. So at that point, no trigger of fertilization and implantation, progesterone and estrogen levels then are going to plummet. And at that point, then we're going to see uterine cramping, endometrial lining getting shed. Okay, so this corpus luteum section relates to the estrogen progesterone levels. It relates to the endometrial lining, what will ultimately again become the placenta and where the amniotic sac and basically the baby's home. Okay? And again, we get into fertility, heredity, genetics, heredity, fertility, and human development. That's the last unit next semester, kind of a fun way to end. So we'll circle back around to this in a little bit more detail next semester. A couple other things though. Oh, yes. Okay. So when we look at the uterus, and I'll come back to the ovulation and menses. That's the end of this chapter. So anyway, the fundic region, just like we saw with the stomach, and then the body of the uterus, and then we've got again the cervix and the cervical canal, and then the vaginal canal leading up to it. Now, the uterine ligaments. So we see several, about 8 ligaments with the uterus, 8 different uterine ligaments. Many are in pairs. So I put this illustration in again just to show, just the multitude of different ligaments that are helping to keep this in place, to keep this, not just to keep the whole this in place. Pretty amazing. Looks like a deer, doesn't it? Like the ears of a deer and like a fawn or something. Anyway. So wall of the uterus, again, it's the endometrium. And then, so that would be the epithelial lining. So there's going to be some mucosal aspects, certainly there. We would see what's called the myometrium, the muscle layer as well. Okay. And then the serosal layer on the outside, or the most superficial aspect. And again, the uterus is there, as you know, to allow the passage of sperm to get to the fallopian tube, and then to be able to house and feed the baby, right? We have to feed the embryo and feed the fetus, and provide it with a warm, protected place to develop. Now, some of this were not real. I wanted to get to Yes, here we go. The reproductive cycle. I think I think you guys know the basics of your vulva. I think you know about your labia and your clitoris and the vaginal opening. And I don't think I need to go through that. And I mean, I can if you want. But there it is. It's in the slideshow. Okay. But I think more importantly at this point is maybe a few items, and then we'll conclude for the night, because again we do go through this a little bit next semester. But the ovarian cycle, ovaries at the time of birth contain the oocytes in the primary follicles. So meiosis is suspended. So a female is born with the oocytes. They're immature, of course, but you're born with the number of oocytes that you're going to have until you release your first one, and then they start decreasing until you get to menopause or post-menopause. So once you get to puberty and menstruation starts, the oocytes resume meiosis. Now, meiosis, some say meiosis, some say meiosis. They're both appropriate and okay. Now, what this process is taking the primary oocyte is at 46 chromosomes. It has to go through meiosis and become 23 chromosomes, because remember, the sperm cell is 23 chromosomes, the egg cell's 23. When they meet together, we get 46. So anyway, you get half from mom and half from dad, and that process is called meiosis. So all cells go through mitosis. Now, even these, but we can't give. So remember, mitosis is identical. So parent cells 46, we go through cell division or mitosis and have two daughter cells that have 46 as well. So the same thing. So we have a parent oocyte and then two oocytes, both 46. We have to go through mitosis. We have to break up these 46s into 4 23s. We see the same thing with sperm cells. You have a mature sperm cell, 46, breaks up, goes through mitosis into 2 46s. We have to break those into 4 23s. So then one of those 23s will come together with another 23 from the ovary, and that's fertilization. So that's and again, we go through this in a lot more detail and steps next semester. And then again, just, right before ovulation, meiosis is going to stop because we don't want to keep going. We're going to have that. We stop at 23. We don't want to divide it further. So once ovulation occurs, again, that's when that corpus luteum is going to start affecting progesterone, estrogen levels, endometrial lining, basically the preparation hormonally to be able to maintain the pregnancy. So progesterone, so if fertilization does occur and implantation occurs, progesterone levels and estrogen levels are going to stay up. In fact, if progesterone levels drop, that's a problem that can lead to miscarriages. So sometimes a fertility specialist will be able to determine that that's the problem. The problem is you're lacking progesterone. So we're going to just keep going with you and your mate, trying to, procreate, and we're going to give you some progesterone doses to keep the baby in. So then that whole 9 months, they're going to be on progesterone. So birth control pills and patches and shots, and a lot of those have progesterone in them, because remember, guys, you know this if you've been pregnant, even if you haven't, maybe you don't know, but two things when you're pregnant, right? Two things that do not happen while you're pregnant. Well, there's probably more than two, but regarding that area, one is you're probably not going to get pregnant while you're pregnant. So that's good. You know, you're not going to, after the first trimester, you get pregnant. Now you've got, and then you're carrying 2 babies in there, but they're 3 months apart. And then get to the last trimester to get pregnant. You got 3 different babies in there, all with every, that would be wild, right? So no, so yeah, you're not getting pregnant. If you're pregnant, that's good. Well, you're also not having a period usually, right? You shouldn't have a period when you're pregnant either. So both being pregnant or having a period, both of those involve what? Ovulation. So you're not ovulating during pregnancy. So therefore, yeah, well, that's a good thing. So progesterone is going to help with, again, kind of maintaining and keeping baby in. Okay? So no ovulation, no periods during pregnancy. So you're not going to have a menstrual cycle. All right, you knew that already. But anyway, menses. So the menstrual cycle is divided up into 4 sections. You have the first, we're going to start at the period. We're going to start at menstruation. So fertilization did not take place. So for the next anywhere between 3 and 10 days, we're going to be shedding the lining. So, and again, that's a process, right? You're going to have maybe a little spotting, and then it's going to peak out, and then it's going to go back down. And, you go in panty liner, oh, birth control. So birth control pills and patches are progesterone. So you're not going to, if you're not pregnant, but you're taking progesterone, the body thinks it's pregnant. So it generally is not going to be releasing an egg, right? And periods are going to be really light oftentimes when you're on birth control. So that's where I was going with all of that. I think I got sidetracked a little bit, but right. So you don't get pregnant while you're pregnant. Progesterone is released. So how about if you're not pregnant, but I give you progesterone in a pill form or a patch, then your body's probably not going to release any eggs. So anyway, that's where I was going. I think I got. Hey, all right. Well, good. I hope so. Yeah. So, it's good to know you can show off for your ladies, right, guys? Ricky and Craig. Yeah. You can empathize. You can put yourself in their shoes a little bit, right? By understanding their hormonal changes, because I'm here to tell you it's more than just, oh man, again, you're sad again. Why are you crying? Why are you so angry? Why are you so frustrated? What's this roller coasters? And then it's my hormones. And you're like, oh God, that excuse again. No, it's real. It's a real thing. They're mourning a death, guys. If that egg doesn't get fertilized, levels go down. So let's look at that. So anyway, we're shedding the lining, and then so once the lining shed, we're in the post-menstrual pre-ovulatory phase. So after we've shed the lining, hormone levels are at an all-time low. Well, the estrogen and progesterone, FSH and LH, all 4, we start to see a little bit of creeping back up during this pre-ovulatory phase. So we're kind of setting the dominoes back up. Okay. And so LH, luteinizing hormone, that's going to help with that corpus luteum and estrogen, progesterone. Those levels are starting to go up a little bit. We're seeing again that oocyte is moving through the ovary. It's now a primary, now a secondary, now it's a Graafian follicle. We're getting ready now to go ahead and ovulate. Okay, so that post from this whole process is around 28 days, they say, right? It's like in the cycles of the moon. Hey, 28 days. And so, if we're at 7 days of a period and then 7 days after the period, kind of prepping to ovulation. So the beginning of the period to the beginning of ovulation, maybe about 14 days. Okay. And again, these are ranges and we're assuming a lot of things, right? But approximately. So then ovulation occurs, and actually this stage here is the shortest or this phase is the shortest. Ovulation occurs, egg gets released, hangs out in the fallopian tube for a pretty short period of time, 24 to 48 hours is all, and then fertilization doesn't take place. That's when we start this luteal phase. That's when, well, so ovulation, we eject the egg, and then the premenstrual or the luteal phase, we're actually seeing the corpus luteum and the lining of the uterus is being laid out, and we're progesterone and estrogen levels are peaked out right in this area. Okay. And then when fertilization doesn't take place, that's when we go ahead and release the egg, we shed the lining. That's when that progesterone and estrogen level plummets. I put way more info in here than you guys need, because I use this same or similar show when we go kind of go back through this, because there is a lot of chemistry involved. So again, I don't want to get too hot with all of this stuff, because there is a lot of it. Okay. I thought I had a table in there. I don't see it unless it's at the beginning. Sorry about that. I thought I had a graph that had the dates and all of that, but I don't. I must have took it. I must have it's in with that other one that you'll get next semester, because I don't see it in here. Okay, so this one kind of shows that it doesn't have the dates exactly like the other one does. But again, we see FSH, follicle stimulating hormone. That's going to get the ball rolling and start to get some estrogen released, and that's going to trigger and stimulate, along with LH or luteinizing hormone. That's going to trigger ovulation and get that luteinization going with forming that endometrial lining, and basically preparing progesterone and estrogen to be kind of perpetually released if fertilization were to occur. Fertilization doesn't occur, that's that premenstrual phase. So fertilization doesn't occur as we leave that premenstrual phase. We're either going to be entering into the fertilization mode or entering into menses. And so if again, we're going to start getting uterine contraction to help. So that's some of the cramping that occurs, the tired, the energy. There's a lot of blood iron loss. There's a lot of, so again, it's important to keep your iron levels, magnesium, calcium, zinc, iron, those levels, especially right, kind of before in that premenstrual phase, and then throughout your period. Very important to be keeping those levels up, because you are losing blood, and therefore you're losing some energy. So but yeah, some of the sadness, the overwhelming grief that some women feel around their period, it is actually that you're more kind of mourning, like, the death of an egg, the death, the loss of 23 chromosomes, what could have been. That's a lot of stress on FSH, LH up here, progesterone and estrogen down there. Those levels plummet, and this is an every 28-day roller coaster ride. And so yeah, dudes, men, and when I say dudes, I mean dudes, man, you have to cut women, female, not, we have to cut females and women slack, because man, they go through a lot. They deal with a whole bunch of and they work on top of it. I mean, I can't imagine going through the emotional and mental roller coaster of the hormones every 28 days, every 14 days, really. And then, but throughout that 28 days, and having to be able to focus, have to do all the work I assign you guys, having to do your work stuff, having to deal with your family, you have so much to deal with that when the dudes aren't pulling weight, man, that I get it. That's why you happy wife, happy life. It's true. Women need a lot of slack, and they need to be able to take naps. They need to be able to get some me time, and because that cycle of it's 30 to 40 years of that, right? I mean, they go from age 13 years old till they're 14 years old till they're 50, with this. And then, they hit 40 or 50, that menopause, premenopause, and then it's even more erratic, right? So again, very, they're mourning a loss every time, right? We don't quite mourn the loss every time we ejaculate. At least I don't. I'm not mourning the loss of tens of millions of would-be, little buggers. So totally different, right? So we have to be respectful of that. Now, and again, when we do get when they do get to menopause, and it's even more important that they're mourning like a monthly death for like 30 years, and then they get to there, and then they mourn like, I'm never going to be able to do this again type thing death. They wish they were having a period again, right? As many times as they curse their period, from age 18, 15 to 40, they get to 50 and 60, and they maybe want, well, I don't know, I wouldn't know, but anyway, it's a lot of emotion, isn't it? So it's important for us to be cognizant of that. Now, I wanted to say a couple things too, just about fertility a little bit. Again, we talk about it quite a bit at the end of next semester as well, but pH plays a major role, and if there's so many layers to it, but I do want to, so environment and that plays a big role, and consumption, certainly genetics, and plays a role in the ability to procreate and the health of that process. Now, when we're dealing with some of these birth control patches and pills and IUDs, and so much of the birth control aspects fall on the female, and it seems okay initially for them. Maybe it doesn't, I don't know, but for the parties involved, whether it's just this is what I have to do and I'm going to do it, or I have really severe heavy periods, menstrual pains, cycles and cramps are erratic, I'm on the pill or the patch, and everything gets more aligned, and I have less cramping, I have more consistent periods, a very light flow, etc., and so forth. That I'm totally understandable, right? So, but when it comes to just strict birth control, like to prevention, preventing pregnancy, there's a lot of chemicals, and a lot of pills and patches and different things that seems like the diaphragms, that the woman seems to be responsible for. So, there's that, and long term, there's finding that some of the chemistry, you don't want a child from age 14 to age 30. You've been giving yourself progesterone and estrogens in a synthetic form, and keeping everything regular, and then you go to you want to have children, and you're off all of that. There may be some difficulties because of pH changes, new set points, estrogen, progesterone just aren't available naturally anymore. And so, it becomes a real roller coaster. So we see fertility has become a big problem. Fertility clinics are very busy, and so part of it has to do, just like anything, that's dialysis clinics are busy too. There's so much to be said about the health and wellness of the individual and the group, and that goes right down to the reproductive system, hydration, rest, minimal or no alcohol, minimal or no tobacco, minimal or no pharmaceuticals, minimal caffeine and other sugars and sweeteners and all this. There's so many things to follow, and you can follow all those rules and maybe even go crazy following them and still have nothing happening. So I mean, what do you do, right? Sometimes God has a interesting way of working through us and working with us, and sometimes we have to just accept our place and our role and look at other avenues of things. So, but anyway, it doesn't. You know, never fails, right? There's always a body system that is going to be affected by lifestyle choices. So reproduction is no different, and you guys know this, and you've seen the increases. You've talked to people. Maybe you yourselves have experienced these things that I'm talking about. But anyway, I'm going to leave it at that. We've made it through quite a bit of info this semester. You have about 8-9 days to get everything there as much as you can completed, and we'll pick up quite a bit of this next semester throughout the semester. We basically go back through the book. I juggle things around a little bit. It's not quite cover to cover. It's, but anyway, that's it. That's all I have. Do you guys have any questions, comments, concerns? Again, next Tuesday and Thursday, we don't have class, but that doesn't mean if you need help or you want to, whatever, just let me know. I'll be around, and I'll be around over the break if you have questions as well. If you need, if you need office hours or if you need to chat or anything next week, just again, let me know, and I'll see what I can do to help you out. Yeah, they're hangry. All right. Yeah, sorry. Let's see. You're probably teaching me, Fillmore. Yep. Access code. Oh, cool. Good, Lori. Awesome. Good for you. Yeah, that's what I mean. Yeah, that's what I was kind of getting at, Lori. You guys, you go through so much, and you're expected to work like through it, like I mean, the man's world doesn't quite get it. I still, even to this day, what you guys have to go through on a week to week, month to month basis, and then to be expected throughout it all to be able to perform at a peak level, and to have a good attitude, and to keep your wits about you, especially in a medical setting. I mean, man, when you get a whole bunch, and they say that females who work together oftentimes kind of cycle up together, and I mean, yeah, whole ward of 8 or 10 or 12 nurses all on their period at once. I'll be sure not to go to that hospital at least that week if I have an issue. So, but anyhow, yeah. Yeah, bless your heart, Lori. Yeah, Yeesh. Yeah. I appreciate it. Yeah, good luck to you guys. You guys have great holidays, and be safe and be smart, and take it easy. Enjoy the hard work that you put in, and relish in how much you learned, and show off a little bit to your family, and yeah, just keep her moving and have fun. Enjoy the break. Enjoy Christmas. Don't read into all of this stuff about it's going to be a horrible, deathly, everybody's dark, and that doesn't have to be that way. If you guys do your part, and you mask up, and you hang out, and you do what you need to do, I mean, we're all going to be just fine, and we can enjoy the holidays, we can enjoy one another, and we just have to make a few concessions here and there. It could be a whole hell of a lot worse. So anyway, yeah, just be grateful and thankful for what we do have, and you guys have a wonderful Christmas, and Good. Yeah, you guys. In fact, I'm not going to be on here next week, but I will be at the computer. So if you do email me, I can get on if you need to ask questions or chat. But yeah, take this time to just. You don't need to check in. You have nothing to. You got about 8 days to get everything done. So I'm going to leave it at that. And I'm going to stop recording too.